Here we are to use Descartes' rule of signs to find the maximum number of positive real zeros and the maximum number of negative real zeros possible for p of x equals x to the fifth minus 5x to the fourth plus 7x cubed minus x squared plus 9x minus 5. And what Descartes says about the maximum number of positive real zeros is that it corresponds to the number of sign changes in the coefficients of a polynomial when the polynomial is written in descending degree. And so the terms in our given polynomial are in the correct order. So we notice that between the first and the second terms, the sign changes from a positive 1 to a negative 5. Then from a negative 5 to a positive 7 to a negative 1, negative 1 to a positive 9, and positive 9 to a negative 5. Changes 5 times, and therefore there are at most 5 positive real zeros. Now, to find the maximum number of negative real zeros, we examine p of the opposite of x. In this case, this would be the opposite of x to the fifth minus 5 times the opposite of x to the fourth plus 7 times the opposite of x cubed minus the opposite of x squared plus 9 times the opposite of x minus 5. Now notice that the opposite of x to an even power is the same as x to that power. And so the terms with even degree are going to have the same coefficients that they had before. But the terms of odd degree will now have the opposite coefficient. So we'll have the opposite of x to the fifth minus 5x to the fourth minus 7x cubed minus x squared minus 9x minus 5. Here all of the coefficients are negative. There is no change in sign. And therefore, there are no negative real zeros in this example. And so, looking at the next example, the only difference is, after finding the maximum number of positive and the maximum number of negative real zeros, we're also asked to list the total maximum possible for real zeros. This would seem to be trivial, but what we need to remember is that x equals 0 can actually be a zero of a polynomial, and it is neither positive nor negative. So it is not counted in the Descartes rule. So our second example is x cubed minus x squared minus x minus 3. So here there's only a change from the first term to the second term from a positive 1 to a negative 1. So the maximum possible for the number of positive real zeros is 1. When we look at p of the opposite of x, we're going to have a sign change in the coefficient of each term with an odd power. So x to the third will be preceded by a negative 1. We'll still have minus x squared. We'll now have plus x and minus 3. So here we do not have a sign change from the first term to the second, but we do have one from the second to the third, and then from the third to the fourth term. And so the number of negative reals has at most 2. Can actually have 2 or 0 because of additional imaginary zeros that can occur in pairs. In this case, the number 0 itself is not a 0, so we don't have any additional to report there. And so the total for the maximum possible real zeros is 3. Going to the next example, we have 2x to the 6th plus 3x to the 4th minus x cubed minus x minus 4. So no sign change from the first term to the second, but there is from the second to the third, not the third to the fourth or the fourth to the fifth. So the maximum number of positive real zeros is 1. There actually will be one real zero because if we subtracted 2, that would be negative and that would not be possible. For p of the opposite of x, we'll continue to have 2x to the 6th and plus 3x to the 4th. But the minus 1x cubed will become a plus 1x cubed, and the minus 6x will become a plus 6x, and then we'll have a minus 4. So the only change in sign is between the fourth and fifth terms, and so again we have for the possible maximum number of possible negative reals is 1. 0 is not a factor in this polynomial, so 0 is not going to be a 0. So the total for the maximum possible number of real zeros is 2. We have one last example here. P of x equals x to the 5th plus 3x cubed minus x squared plus 6x. We notice there are 2 changes of sign in P of x from the second to the third and the third to the fourth. So the maximum number of positive real zeros that can occur is 2. For p of the opposite of x, we'll have minus 1 times x to the 5th, minus 3 times x cubed, minus x squared, plus 6x. I'm sorry, that's also going to be a minus 6x. So all of our coefficients are negative. There is no change in sign. So there will be no negative real zeros. This time, 0 is a 0. So we'll have to add 1 to the possible number of real zeros. And so for real zeros, there will be a possibility of 3. The reason that x is a 0 is that x is a factor of the polynomial. If we factored out the x, we'd get x to the 4th plus 3x squared minus x plus 6.